All right, welcome back to part 2. So, we're now going to talk about limiting reactants. Now, these can be kind of confusing for people, so it's important that we pay attention. Here, it can get a little bit messy, but the concept itself is pretty simple. So, if we're looking at a container that contains a stoichiometric mixture, meaning there are entire moles of one thing to another, at a certain point, the reaction is going to run out after the reagents have reacted enough. This is then going to limit the amount of the reaction that can proceed. So, for example, in this reaction, we have the ratio 1N2 to 3H2 is going to make 2NH3. And so for every 1 N2 that we have and every 3 H2s that we have, we're going to make 2 NH3s. So if we have the same number of ingredients, or if we have the correct ratio of ingredients, we will always be able to make NH3. However, if you have more of one reactant than another, for example, there are more of these N2s than there are of the H2s in a stoichiometric manner, then you are going to have a surplus of N2, and your limiting reagent or your limiting reactant is going to be the opposite of whatever you have left over. If you have fewer moles of one thing than another, the one that is going to make fewer moles of your product is going to be the one that is going to limit your reaction. So the limiting reactant or reagent is going to be the one that runs out first. So what does that mean? In this, H2 ran out first. That's why there's no H2 left over in the other reaction. So, if we want to determine the limiting reactant, we need to know the amount of product that is going to be formed. So, with this reaction right here, when we take methane and treat it with water, we get out H2 and CO. So, in this reaction that we see here, we have CH4, 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 and CH4. We have all of these things reacting. We also have another CH4 right there. So we have a total of 5 CH4s. And the carbon part, you can see on the other side, right? This big black dot in each of these. Now, as this reaction occurs, there are only 3 carbons in the product at the end, which means that 2 of these are going to be left over. That means that this is our excess reagent, which means that the other reagent is going to be our limiting. Our limiting reagent is when the reagent is when the reaction has to we know that we've used up our limiting reagent when the reaction has to stop because there is no more of the limiting reagent left over. And so, the amount of water that can form, or the amount of products that can form is limited by the water, which makes it the limiting reactant, leaving methane in excess. Okay, so the steps to figure out how to use how to find the limiting reactants are this. You want to write and balance the equation for the reaction. If you don't know what the reaction is yet, you need to write it out, and it needs to be balanced. Then, take whatever kind of masses you have of your reactants and convert those to moles. It's going to need to be in moles. You can use the number of moles of reactants and the appropriate mole ratios, so the reaction equation itself, to determine which reactant is going to be the limiting one, which one is going to make less makes less product. You can use the amount of the limiting reactant and the mole ratio to compute the moles of one of the products. So if you have more than one product, only pick one. And we'll get into what that means in just a second. But you're only going to want to pick one. You're going to use both of the reactants, only one of the products. You'll convert from moles of product to grams of the product to find the molar mass at the very end, if that's what the question asks, but it is not required in all problems. Not always required. Okay, so for example, we know that chemical A reacts with chemical B. We react 10 grams of A with 10 grams of B. We need to know what else we would need to know in order to determine the amount of products that would be produced. And so a couple of these things are going to be, since we have grams, we need to be able to convert that to moles. So we would need molar masses. And we also need to find out which is going to be our limiting reagent. And one of the ways that we'll find that out is to find out how, or what ratio, I should say, the reaction occurs in. So whatever ratio the reaction occurs in, that's what we would need to find out, which means we need to find out what the equation is. So, to determine the mass of product that's going to be produced when we react 10 grams of A and B together, we need to know the mole ratio between the reactants, which is going to be the equation, and we need to know the molar masses. Then we can find out what the limiting reagent is. So if this is our reaction, this is, let's pretend that this is our equation that we need. So this is what we have. We have A plus 3B going to 2C. Now we know what the ratio is. We have a 1 to 3 reaction ratio from A to B. But we also have the molar masses. We can figure out what the equation is from these molar masses. So the way that we'll start is we'll pick one of the reagents, A, and we'll start with the amount of A that we have. We have 10 grams of A, so 10 grams of A will go here. The molar mass of A is 10 grams per mole, so the grams are going to go on bottom because we need to cancel out units, and we will get 1 mole out. This way, we will find out the number of moles of A we have. Here, we have the same situation, 10 grams of B. We'll just use the next one. For every 20 grams of B by the molar mass, we know that we will get 1 mole of B. And so we end up with 5 moles, or 0.5 moles of B. So, with the number of moles that we have, we can now we can convert one to the other. So, moles of A, this is one way of doing it. We'll take moles of A, and we'll use the ratio. For every 1 mole of A, there are 3 moles of B, which means that we need 3 moles of B to react with all of the A. Remember, this is what we found. We found this. It wasn't given to us. We found that it had 1 mole of A. It wasn't given to us. We need 3 moles. However, we do not have 3 moles. We only have 0.5 moles, so we already know right off the bat that B that this is our limiting reactant. B is our limiting reactant. So if you end up doing this reaction and you need more moles of something than you have, then you will be able to figure out what the limiting reactant is. We can also see how much we are going to produce by starting with B. So we know that we have 0.5 moles of B. We'll use the ratio of B to C right there, and we will be able to solve for the number of moles of C that is produced. However, we are looking for the mass, so we're not quite done. We'll take the moles of C produced, use the molar mass of C right here, and we will find out that that is going to be 8.33 grams. So we can't just simply add the total moles of all of the reactants to decide which reactant is going to make the most product. It's not going to always just be 1-to-1. You have to think about how much product can be formed by using what we're given. So this could be seen here. So we have 10 grams of A and 10 grams of B. And even though they're equal, because this reacts in a 1-to-3 ratio, we are not going to have we're not always going to have the correct number of moles. Okay. So, continuing, we can also do this in a different way. So approach B. Approach A was we converted from the number of one reactant to another, but we can also approach this by finding the number of product that was formed. So again, start by balancing the reaction. We'll take the number of the masses and the moles that we have, and we'll take the masses and convert them to moles, and then we will take those moles and convert that to product formed, and we'll do it twice. We'll do it once for each reactant. Whichever of these makes the least number of moles of products is going to be your limiting reactant. And then we'll just convert back to grams. So, chemical A reacts with B. We need to know what other information we'll figure out. We already know most of this stuff, right? Determine the mass of product when we react 10 grams of A with 10 grams of B. We need to know the reaction's balanced equation, and so we will go there. We're going to use the same equation, all of the same information that we had before. It's identical. And we will then again convert from the grams to moles. This is the same exact thing we did before. We're converting straight into moles of A and moles of B. We will then take the moles of A and moles of B, and instead of converting one into the other, we're going to convert both into the products. So 1 mole of A, 1 mole to 2 mole ratio gives you 2 moles of C. 0.5 moles of B, there's a 3-to-2 ratio, gives you 0.33 moles of C. And right away, I know, because this one makes fewer moles, we have our limiting reagent. Keep in mind, your limiting reagent is exactly that, a reagent. So your reagent is B. It's not C, it is B, not C. From there, we can convert that to the number of grams, and we'll end up getting the exact same answer. This is the exact same calculation. Well, it's very similar. No, it's the exact same calculation that we ended up with on the previous page. Okay, go ahead and try this out, and let's reconvene in a second. So, which of the following reaction mixtures would produce the greatest amount of product, assuming all went to completion? Each involves the reaction symbolized by the equation. If I have 2 moles of H2 and 2 moles of O2, how is this going to work out? Let's try one. So 2 moles of H2. This is what we'll start with. We're starting without grams, which is going to be great. 2H2, we'll use the equation for every 2H2. And I'm going to do part B, or approach B. For every 2H2O, well, H2 cancels out. 2 times 2 divided by 2 equals 2H2O. This is for A. For O, we have 2 moles of 2 moles of O. We'll convert that for every 1 O to H2O, we'll get 4 H2O. Now, instead of doing it like this each time, because that's going to be 2 equations per, I'm going to switch to approach A that we just went over so that I can see what the ratio I would need would be. So if I had 2 moles of H2, I'm going to convert that to O2 to see how many moles of O2 I would need. For every 2 H2, there would be 1 O2, which means that for every 2 moles of H2 I would need 0.5 moles. I would need 1 O2. So, because this and this are not a 2-to-1 ratio, I know right off the bat H2 is going to be my limiting reagent. I also know that the H2 and H2O have the same coefficient. So, however much H2 I will be making, as long as this is my limiting reagent, I will be making the same number of moles of water. So this is going to give me 2 moles of water. B, well, the required amount of oxygen is 1 mole of oxygen for every 2 moles of H2O, or of H2. Since I have 3 moles, oxygen is still in excess, so this is going to give me 2 moles of H2. Now I have 2 moles of H2 and 1 mole of O2. That is a stoichiometric amount, is what that means. That means that I have exactly the number of elements that I need. And so this is also going to give me 2. Now, the ratio is 2 to 1 here. So I need 1 mole of O2 and at least I need 1 mole of O2 and 2 moles of H2. However, I have 3 moles of H2, which means that means O2 is my new excess reagent. Since the ratio is 1 mole of O2 to every 2 moles of H2O that are made, I know that 1 to 2 is going to be my ratio, and so for every 1 mole of O2 used, 2 moles of H2O are going to form with excess H2 present. And so we can say each produce the same amount of product. Okay, try this out, and then I will explain. Okay, so for the following equation, A plus 3B goes to 4C. I have 3 moles of A, and I have 6 moles of B. Which of the following is true after the reaction is complete? A is the leftover reactant because I only need 2 moles of A, and I have 3 moles. Well, I don't know if that's true. I see a 1 in front of that, so I don't know if that is correct. A is the leftover reactant because for every 1 mole of A, 4 moles of C are produced. That is not necessarily true. We don't know that per se. But in this case, it is likely correct. But B is the leftover reactant because I have more moles of B than I do of A. Now, this is incorrect. This should be incorrect because it doesn't matter if you have more moles of one or the other. It has to do with how they react with one another. And since, yes, I have more moles of B, but I need to use 3 times as much, and I do not have 3 times as much. B is the leftover reactant because 3 moles of B will react with every 1 mole of A. 3 moles of B will react with every 1 mole of A. I have 6 moles of B, which would take up 2 moles of A. Now, that's going to leave over a mole of A. So I don't think that this is going to be the answer either, because I think that the reactant is going to be A. The leftover reactant is going to be A. A is the leftover reactant, so we can cross out these because B is not our leftover reactant. We can cross out, or now we have to choose between these two. A is the leftover reactant because I only need 2 moles of A and I have 3 moles. That is probably the closest because I do only need 2 moles in this reaction because I have 6 moles of B, which would mean that I need 2. So let's do the math behind that real quick. I have 6B for every 3B, I have 1A. This gives me 2A needed for the reaction. I would need 2A. I only need 2 moles of A, but I have 3 moles, which means I would go with this answer. It's going to be the leftover one because I only need 2 moles, and I have 3 moles. I was mistaken when I said that because there was no 2 in front of this, then it would not be necessary. And that is indeed the answer there. Okay, try this one out, and then we will continue. Okay, so how many grams of NH3 can be produced from a mixture of 3 grams of each of nitrogen and hydrogen by the Haber cycle? So first, let's find out some molar masses. As soon as you see grams and you see that you are going to need to go from one thing to another in an equation, you're going to want to find the molar masses. This is going to be 28.02. This is going to be 1.01, and I believe this is 17.03. Let's see, 14.01 plus 3.03 gives me 17.04, 17.04, and on my mistake, this is H2, so that's actually 2.02. Okay. So, this is how I will set this up. How many grams of NH3 can be produced from the mixture? We have 3 grams of each, so I'm going to make one of these. I'm going to start with what we have. We have 3 grams, 3.00 grams. Let's start with N2. N2, we'll divide that by the molar mass. So these are all in grams per mole, right here, here, and here. And what we'll do is say 28.02 grams for every 1 N2. We'll then use the stoichiometry of the equation and convert that to the amount of product that we have, which means 1 N2 for every 2 NH3. Now, you can stop there if all you're trying to do is figure out what the limiting reactant is. However, it's asking for the grams of NH3, so I'm just going to go ahead and go all the way to grams here. So 1 NH3 is going to be 17.04 grams. And when we do this reaction, we say 3 times 2 times 17.04 and divide that by 28.02. The answer we get out is equal to 3.65 grams of NH3. I'm going to do the exact same thing that I did with N2, but I'm going to do it with H2 now. And so we'll set it up again. We have 3.00 grams of H2. The molar mass of H2 is 2.02 grams for every 1 mole of H2. The mole ratio of H2 to N2, or NH3, is going to be 3H2 for every 2 NH3. We will then convert that to grams and say for every 1 NH3, there's 17.04 grams. And so I'll do the exact same thing I did before. That's going to be 3 times 2 times 17.04 on top, and we have 2.02 times 3 on the bottom. That gives us 16.87, which we can round to 16.9. 16.9 grams of NH3. So I am limited by the amount of N2 that I have. And so this is going to be my answer. There we are.